Today we will delve into animation and video in computer graphics. The term animate suggests life and motion, and in digital context, animation involves graph movement across a canvas. However, how do we display an animation and what constitutes a video? Understanding animation and video. We have learned about images so far. When a series of related images is arranged and displayed on a screen consistently in rapid succession, the subject within these images seems to be in motion. This perceived motion is an illusion created because the display refreshes the image quickly. This refresh rate, referred as FPS, measures how quickly the display updates or redraws the image on the screen. A video is essentially a sequence of such images referred to as frames that are captured and exhibited at a specific frequency. By pausing at a specific frame within this sequence, we obtain a single video frame, which is essentially an image. This principle applies to any sequence of video frames. In essence, animation captures the movement of a graph on the canvas, while a video comprises a series of images displayed rapidly, creating the illusion of continuous motion. Drawing a video on the canvas. To represent this visually, let's consider a timeline. Imagine a car moving at constant speed. If the car takes 10 seconds to move from 0 meters to 20 meters, we can map this motion using a graph. Here the x-axis represents time and y-axis represents the x-coordinate. As we progress from time 0 seconds to time of 10 seconds, the car moves from 0 to 20 meters. But what lies between these points? This is where interpolation comes in. If the car moves at a constant speed, the position time graph has a constant slope according to the principles of calculus. The function that fits this uniform slope best is linear interpolation. Implementing linear interpolation helps us determine the value of x at any given position using the t-value. Besides linear interpolation, there are other forms of interpolation such as quadratic, cubic, exponential, circular, elastic, bounce, and exponential reversed interpolations. Now let's contextualize this interpolation in the context of a circle on the canvas. Suppose we want to represent a circle in motion with interpolation techniques. We can seamlessly portray its motion, whether it is a graceful rotation and expanding or contracting motion or any dynamic transformation, infusing the life into the circle's depiction on the canvas. Understanding interpolation is crucial to bringing the elements within our canvas to life, allowing us to create visually engaging and dynamic animations.
So now let's create an animation using the P5JS interface. If we want to move a circle, then we should declare its initial x and final x and y positions. Then we declare the t value. The draw function is repeated 60 times a second, so each step we increase the t value by 0.01 and limit it up to 1.0. Then we draw the circle at the left position, and this is what we get. Now that we want to animate the size of the circle, we declare the initial size and the final size of the circle. Then we lerp the radius of the circle using these sizes using t. We can try different values for the initial and final sizes. Now let's rotate the circle. Then we declare the initial rotation and the final rotation. But a circle is completely round, so we cannot rotate it. Hence, we declare a rectangle. A rectangle can be rotated using the push-pop method. We put a push before the rectangle statement and a pop after the rectangle statement and use the rotate and translate functions to draw the rectangle at specific coordinates and with a specific rotation. Then we lerp the initial and final rotation by t and we get a rotating rectangle. We can also change the initial and final rotation variables. Note that these are expressed in radians. Thank you everyone for coming so far. This was the last video of the Introduction to Computer Graphics series. With this you have learned the background knowledge of how CGI works. It will help you in the future to learn apps like Blender, Godot, Inkscape, processing, etc. We will also upload videos on them every week. Also, we are releasing new Minecraft series on our channel, featured and link in description below. Thanks for watching.